The first one was this. Ready? I'd like you to darken H, please, and write the word on. H is on the circle. Now, draw in the angle EHG. We're on our notes on our iPad. That's your reference booklet. It's supposed to be on right triangle. Okay, which I will get for you while you find that. Oh my gosh, I actually put my iPad. I don't know. The pen. On that note. Okay, this red angle. Go like this with your hand. Say head on. Head on. Arms in. Arms in. Hands grab. Hands grab. What kind of angle is that? Inscribed. You should know that. That's inscribed. Head on. Arms in. Hands grab. That's inscribed. And it says the measure of a central angle to its arc the same. The smaller angle of inscribed is half. It's plain. So trace the arc here. Trace the arc. How many degrees? 180. Okay, so what's back here? We forgot to stretch out the diameter, Mr. Billings. You're right. Okay, so there's your first undercover right angle. When you have an inscribed angle in half a circle, better known as a semicircle, there's automatically going to be a right angle there. That was the first one you encountered. The second one, can you darken the end of the radius there? And now sketch yourself a nice tangent. And you're very multi-talented, so I expect you to actually trace and sing at the same time. Ready? If tangent to a radius, 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 if tangent to a radius, right angle at the edge. That is your second undercover right angle. So your first one inscribed in a semicircle, second one tangent to a radius, right angle at the edge. Now, when I say turn to a neighbor and describe these two, this is what I want to see. You're going to use your lips, but this time I'd like you to describe also using your hands and your arms as props. Study show, basically, the more body parts you involve in learning, the more you learn. That's why when you read, you don't just use your eyeballs. You use your eyeballs, your lips, your fingers, and highlighters. Okay? So, I want to see you all talking, pretending like you're in the geometry version of ASL class. And I'd like you to demonstrate these two undercover right triangles to each other. So, buddy up, start describing with hands and arms, faces, knees and toes. Joseph is home today. He already told me that. Ready? Here is your third undercover right angle. Step one. On this chord, eyeball what looks like the middle. Eyeball what looks like the middle. And then put your hatch marks there. So we're on the next page because I lost you. Okay. Now through that midpoint, I'd like you to draw a radius. Yes, we're getting there. You could also trace a diameter while you're at it, because what I'm about to say is the same for both diameters and radii. So start with this. Write the word if bisect. Put in parentheses a radius. But I'm going to just say the word if bisect. That radius bisects that chord. Ready? I'd like you to trace the radius again. Trace the chord. Trace the radius. Trace the chord. What kind of angle's going on there? Right angle, perpendicular. Yes. So if bisect, then they're going to be perpendicular. There's your next undercover right angle. I warned you right off the bat. Circles really is almost 50% right triangle stuff again. Okay, so you're going to see it again and again. Notice it goes both ways. That means it's biconditional, which means the opposite is also true. So the second one, draw a perpendicular radius. Start by drawing a perpendicular radius for For the second one, draw perpendicular radius. And then it should be pretty obvious that that smacks through the midpoint. So both are true. If bisect, then perpendicular. If bisect, then perpendicular. That's not twice. If bisect, then perpendicular. If bisect, then perpendicular. The converse is also true. If perpendicular, then bisect. Say it. If perpendicular, then bisect. Again. If perpendicular, then bisect. That's about 50% of the lesson. The next two are pretty simplistic. Then we're going to do one teacher example, not two. I'm going to shorten that up so you can get your homework done in class. Ready? That's my goal. Ready? Trace that radius. Now cut that chord in half. Because I've got this lovely little palette that I don't have to pull up each time. Oh, no, it's not congruent. Well, kind of congruent chords. Technically, it should be. I'm sorry. You're on iPad, so this works. If bisect the chord, it should say bisect the chord. If a radius bisects a chord, what do you think it does to the arc? Yeah. If it bisects the arc. Again, this double arrow means vice versa. It goes both ways. If a radius bisects the arc, bisects the chord, bisects the chord, bisects the arc. Oh, okay. Do you see how the blue cuts it? Okay, there we go. That's pretty straightforward. Cut the chord, cut the arc. Now, the next one. Distance. You guys know distance in driving in what unit? Distance in what? Miles, okay. You're a swimmer. Short course. What are you swimming in? No, short course. Short course is yards, long course is? I know my swimmers are. Okay. Let's say you are an ant and you're walking. What is your distance most likely? Centimeters, maybe. Okay, so that's what you guys think in distance. But distance in a circle is a physical segment. Really important you catch that. It's a physical segment. We did this last night in the videos. That's why I'm going kind of fast. The word distance in a circle is measured from the center. From the center. Listen and you draw. Take my words and make it into a drawing on this diagram. The chord AB is 5 centimeters from the center of the circle. And chord CD is 5 centimeters from the center of the circle. I'll say it again. The chord AB, the distance is 5 centimeters from the center. Chord CD, the distance is 5 centimeters from the center. Okay. Let's see where your instincts were at. Ready? Your 5 should be here and here. Thumbs up if you drew that. So, okay, if you didn't, now let me add a couple notations there. So this was 5 centimeters. This was 5 centimeters. That blue segment distance, it both bisects the chord and it's also perpendicular to the chord. So when you see in story problems or some sort of description from the center, instantly there's a segment there and makes a right angle and bisects automatically. This last one, super easy. Everybody trace that distance. Trace the distance. That's equal, right? Notice I'm using the word equal, not congruent, because distance technically is a measurement. It's a number. equal distance. Trace the chords. If the chords have equal distance, tell a neighbor, what do you know about the pink? Yeah, congruent chords, equal distance, congruent chords. Okay, ready? Go to the next page, please. Now, there is a problem we're going to skip over here. So it's not the first one, it's the second one. So cross out the second one so you all don't accidentally do it. Okay, time-wise, I have found that we really only need to do one example and you pretty much got it. Okay, read, label. Read, label, go. So the second one we're skipping, the first one we're doing. Read, label. Where the radius goes is a spoke in a wheel there, Whitney. Think of it as a spoke in a wheel. Read, label. Okay. So far you probably have something like this. Oh, you have the radius length, and there's only currently one radius. You traced it. You have 13. If you're really on top of it, you stuck the meters on there. And then we have here A to B. The whole thing is 24, but there's a right angle there, which automatically implies this is 12 and 12. Okay. And it says find all possible segment lengths, angle measures, and arc measures. How on earth do you do that? It's like, I already found everything. Not any range that doesn't tell you anything about the arcs of the angles. No, there's no sticky notes either. There's no inscribes. Yes, it doesn't.
You draw a line between A and O.
Okay, how about we do that?
And then you can use Pythagorean theorem to find the length of A to the chord, and then you can find Y to the chord.
Nice call. Okay, everybody, can you finger pinch O to Y? Finger pinch it. You need to feel this. Finger pinch it. So O to Y. What's that length there? Okay, ready? Finger pinch A to O. What's that length? 13. Okay, remember what I said about radii? Even if you can always draw in or move radii. Here's a hint. If you don't see a right triangle, make one. If you don't see a right triangle, make one. Okay? I know this is 13 because it's a radius. Ready? Now, my friends who have a right triangle, let's trace it. See that yellow right triangle? Let's pull it out. Trace it. We don't have all three now, my dear. This is 12, right? This is 13. And let me make this pink squiggle. See pink squiggle? Do we have pink squiggle? No, we don't. Find it. Go. We'll call that X. Oh, no, not drawing to scale. If I drew everything to scale, I basically wouldn't sleep. Do your own math, guys. You absolutely need a calculator. You may have one out now. Actually, you'll need one out in a few minutes anyways. All right, ask your neighbor what they got. Go. Are you not done? Oh, sorry about that. Too fast? All right. So we found we're not done with your segments, guys, just because you're not done. That's 5. So pink squiggle is 5. Ready? I want everyone to trace the 13 right there. Trace O to Y, the 13. Okay? Now, trace the 5 that you just found. Ready? See light blue? Find me the light blue. Do not say it out loud yet. Let people think it through. Find the light blue, please, quickly. Find the light blue. Once you found the light blue, ask your neighbor what they got. Okay, I need brutal honesty right now. Absolute brutal honesty. Okay? Hands up if you have no clue where the name came from. Be honest. Be honest. You don't know where the name came from. It's okay to ask. There's 4 of you at least. I know you do not know where the name came from. Okay, ready? Turn around and ask the person where did A come from and ask them really sarcastically. All right, now we have all the segments, but we still have no angles. So let's find ourselves some angles. I'd like you to physically trace, please. Ready? A, O, Y. Do you see that's a pizza slice angle, better known as what kind of angle? Not inscribed, it's connected to the, so it's central. Ready? Now take that angle, pull it over here to your pull apart triangle. Now look on your green sheets to find that angle. We're going to use inverse SOHCAHTOA. This is now our opposite. This is our adjacent. This is our hypo. We honestly could use any one of them. I tend to default to sine, so I'm going to write inverse sine. Opposite over hypo equals theta. Inverse sine, my opposite is 12. My hypo is 13. That theta is this green right here. Okay, you find that and then find all possible arcs and angles. I'll give you about a minute and a half. Round your angles to the nearest whole. Round your angles. You're going to need to share calculators. If you don't remember how to put that in your calculator, ask your neighbor, go. What did you ask about? Round to the nearest whole degree. Round to the nearest whole degree. Do you have a scientific calculator? Okay, so you're going to take this one. Do you mind, Joseph? Okay, so you're going to go 12 divided by 13. Put the equal sign. Put the equal sign. Good. And 12 divided by 13. Put the equal signs. Second function sign. Yes. Okay, you're going to hit 12 divided by 13. Put the equal sign. Second function sign. You should be getting the second. I want to make sure you guys get where you want to be and where you should be. All right. What'd you get? 12 divided by 13, hit the equal sign. And then second function sign. All righty, guys, take a peek. You should have gotten 67. And then you find the arc all the way around. You just take 6 minus 67. Okay. So you're like, wow, you mean we have to use Pythagorean theorem? We have to use SOHCAHTOA? Yeah, we do. All right. Ready? Skip this one down here. Go straight to the next page, page 4. You have 35 minutes to finish pages 4 through 8. If you want extra credit, go. So I would like you to scoot back in your quads, please.